Welcome back to the bench, and now we're going to look at this avatar power supply with a burnt tantalum capacitor there and a burnt resistor here. So I'm going to take these transistors out and this one, just make sure they're okay. And I notice on this tantalum it's actually blown short. The other one doesn't measure short. And what is interesting is that the fuse didn't blow. So hopefully, if we can clear these shorts, might be able to bring this back to life. So if you notice, there's a lot of flux left over from the factory. So I think I really want to give this a good clean over. I don't know how conductive that gets over time. And there we go. Better than new. And I've replaced all those tantalums now for electrolytics. So it shouldn't be a problem. So the interesting thing about this power supply is that the fuse on here didn't blow. And if we look at the schematic, this is that tantalum that I think went short. So when that blew and went short, it was basically pulling current through this resistor. That's the one that blew up. The transistor's fine. And this chip is only really controlling the base of that. So the current, hopefully, would have just gone straight to that resistor, which blew before the fuse. So what I've managed to do is recreate the circuit on the top. So we're not using any of the holes, mainly because the actual socket itself has got carbonised. So I wouldn't want to risk that. So what I have to do next is just cut any traces around the damaged area, so no traces go anywhere near the burnt area. And then I have to just short out the sense connections here, so the power supply has some idea of what's going on. So I was able to cut a clear line down here. Nothing comes around here, so that completely isolates this part of the circuit. Okay, I'm just going to test this with the mains. I'm going to use my light bulb current limiter. I'm just putting a 1 amp fuse in this plug, just in case. Okay. Let's see what happens. We got plus and minus 15 volts. I'm actually pretty shocked. Well, that's really good. Let's get the thermal camera out. So it looks like the hottest thing is the little 8-pin chip and the little chip that's doing the controlling. So yeah, nothing's getting hot. Obviously it's under no load at the moment, but yeah. I don't know if you saw Alex Ball's video on the Arp avatar, but I was in communication with him because I was quite intrigued to find out, because it's serial number 1, you would have thought, because it was made in America, that it would be 110 volts. And he showed me some pictures of when they came to London to demonstrate the Avatar, including Pete Townsend was there as well. So obviously when I checked the service manual, it shows you very clearly how you can wire it up either 110 or 240 volts. So that cleared that up, and I was able to just make connections to the mains via like that. So my big dilemma now is this a satisfactory repair? Yeah, there's no way I can put this PCB back into circulation with its burnt PCB, especially being in the power supply. You could cut it out and refill it and retrace it, but I think I've done enough damage to this board already by cutting these traces. And although it's serial number 1, we don't have to throw away this PCB, obviously. This can be kept with the unit. And as you can see here in the service manual, they have given us a beautiful picture here of what the PCB layout looks like. Now, I'm very used to making my own PCs back in the day from the Usynth website. This is a fascinating guy. He put up loads of modules. And if you're really interested in learning electronics, this is definitely the place to come. For example, there's the Steiner VCF here, which he made for the Mini Brute, or ended up in the Mini Brute. And he gives you all the circuit diagrams and also a complete description of what's going on. On this web page here, you can see we have the actual layout for the PCB. And I used to use print this with a laser printer onto a magazine paper, and then actually make my own PCBs and drill the holes and everything. So I was quite used to this sort of more artwork based way of making PCBs. So I brought that image into Photoshop, and I was able to separate out the silk screen, and I also brought a high resolution Arp logo to replace the low resolution one from the image, and able to recreate the PCB layout. So I was able to export this out like this and load it into Kicad, and this is quite a fun way of doing it, and I was so pleased that all the sizes lined up. It was quite miraculous, really. This is how the PCB ended up. It's basically a single-sided PCB. And what I really love about PCBWay is that there's a plugin in Kicad itself. So when you just click that button, and it loads all your Gerbil files, drill files and everything, puts all the dimensions in. It couldn't be easy, really. And on this particular PCB, I wanted to make the board 2mm thick, so it's a bit stronger to hold the transformer. I wanted a red PCB to kind of match the Avatar, keep with the white silk screen, and I went with immersion gold, really just to show off the graphics, really. And the copper, I upped it to 2 ounces. As it's for the power supply, I thought it would be a little bit safer, and I did notice on the original that they kind of tin the traces as well, so we went for 2 ounces. Well, I've just noticed PCBWay has a new online Gerber viewer. So let's drag our zip file containing our Gerbers, and now we can check everything. The Gerber viewer is just for reference, with some features still being improved. So this is a new thing that they've added. Let's check out the bottom. Oh, everything looks amazing. So make sure you subscribe if you want to find out what happens with this PCB that I've made. Can't wait to get it from PCBWay.com, and I will then transfer any components from the original board that we need on here. Others I might actually replace, like these diodes on the bridge rectifier. Try and keep as much original on the original board as possible. So yeah, if you like that, Stay tuned. Catch you next time.